to why is water important to life. Have you ever been in a hospital and received an IV? Or maybe you know of someone who's received blood through their IV? Well, that's very important to life, and both of those solutions are water-based solutions. Water is actually known as the universal solvent, and that's what we'll be focusing on in this unit. So what is a solvent? A solvent is the main part of a mixture composition which dissolves the solute particles to make a solution. So a variety of vocabulary words in there. The solvent is typically water. It dissolves other particles into it, like red blood cells, white blood cells, platelets, maybe electrolytes in that IV bag. But the water does the dissolving, and together the solute and solvent make a solution. We have various words to describe a solvent and its concentration. One of the terms is concentrated and dilute solutions. Notice here, this is the concentrated solution, this is the dilute solution. The reason we can compare these two is because they have equal amounts of water. Therefore, when we look at them, we can see that this one has more solute in it, meaning more dots, and this one has less solute in it, being less dots. The empty space here is considered the solvent, and then these dots are actually the solute in there. By definition, a concentrated solution has a high amount of solute in the solvent, as opposed to a dilute solution has a low amount of solute in the solvent. So that is just one way of describing solutions and how they are made. We're going to talk actually about how they're created. How does that water dissolve things? And what we use the term solvent attacks the solute. So if water is the universal solvent, what it does, it actually tries and attacks the solute and tries to take it apart and send it throughout the solution. In this case, we have our solute, the sodium chloride, and our water pictured in the diagram. In the second diagram, you can see the water is surrounding and carrying off pieces of that salt crystal. It's attacking the salt crystal and carrying it throughout the solution. And in the third picture, you can see that those particles are diffused throughout the solution, meaning spreading out throughout the solution. One thing to notice, if you look very closely at the second picture, as this water is surrounding the purple ion in the salt solution, the red oxygens of the water molecule are surrounding that purple one. In this one, though, the gray hydrogen atoms of the water are circling the green chloride. So those water molecules line up in a specific way as they attack the solution. We're going to look at a short video here to show this in action.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
So from the video, you can see that that water will attack the solute and take it away, diffuse it throughout the solution. What we're looking at today is the factors that are going to affect that. How fast can we make something dissolve? What can we do to make something dissolve faster? And what I want you to do is take a moment to think about that. What factors can make the process of dissolving happen quicker? So your assignment is going to be to collaborate with a group to determine what factors will make something dissolve quicker. Then you will design an investigation using 4 Boyden cubes. And you're going to make careful lab records of your procedure, your data, and your analysis. And what you're trying to figure out is, how can I get quantitative data, that means data with numbers, that show if I change certain variables, things will dissolve faster. Again, these 4 Boyden cubes, make sure one is used as a control, test the other 3, make sure you have lab records to turn in. After that, you then need to complete a worksheet on concentration and solution creation. Time allotment here is 25 minutes for lab, 15 minutes for worksheet. Good luck and go learn.